there's a second way to find the slope of the tangent at a particular x value. Call it A. So again, just drawn up here a curve. Doesn't matter what the curve looks like. The process is all the same. However, what I'm going to do is think of generating this. We'll start with a secant line. So I'm going to go out to another point on the function to get a secant line. But instead of calling it x, that second point, go out to an x value. Here's what I'm going to do. I'm just going to say I'm going to go in the x direction a number of units, call it h. So I'm going to go out here, yeah, that's fine, a certain number of units, h units. So instead of saying I'm going to go out to just an x value out here, I'm going to say I'm going to go out h units from A. Well, what does that make the x value then if I go out h units from A? Well, it makes it A plus h is the x value there. And so that establishes my second point for my secant line. Again, what I'm looking for is this tangent slope. But to get to the tangent slope, I need to start with the secant slope. Now so if I do that and make that my second point, so this is A, f of A, again, because my function is y equals f of x. What does that make my second point though? Well, the x is A plus h, that's my x value of that second point. What does that make the y value? Well, the y value would be, plug in the x to be A plus h, so the f of A plus h. So we could represent that without knowing the function. So my p point is still A f of A, but my second point, instead of, on the first way we did it, definition 1 we called it, it was x f of x, which, oh, that's pretty good, pretty nice and easy. But this is going to turn out to be somewhat nicer in most cases, so that's why we're doing this. But the x value is A plus h, and then the y value is f of A plus h. Okay? All right. So my secant slope then, doing those points like that, the secant line slope would be difference of the y's over difference of the x's. y2 minus y1 over x2 minus x1. Well, what's my second y? Well, let's call the second y this f of A plus h. Minus from that the first y, which is just f of A. And then difference of the x's for the slope formula there. So it'll be A plus h, second x, A plus h, minus the first x, which is A. So we get that? Difference of the y's over difference of the x's. Now, the beauty of doing it this way, this method, is, well, the top's what it is, but what happens on the bottom there? The bottom, the a's go out. The denominator is just h in that case. Okay? But that's the secant line slope. I'm interested in the slope of this tangent line, right? Call it T, the tangent line, your tangent line. So let's think about, all right, so that's the secant line slope. What would be the slope of the tangent line based on that? Well, what I would do to get the secant line slope is I would make this h ever and ever smaller, right? Just keep incrementally making that smaller. So essentially what I would want to do is shrink the h down to nothing. In other words, I want the limit as h goes to 0, to nothing, right? Isn't that what I do to find that secant slope? I mean that tangent line slope? Shrink the h down to 0. So this is going to be the limit, not as x approaches a, but as h goes to 0. And then I just do this function, slope of this secant line. So it'll be the limit as h goes to 0 of this secant line stuff. F of a plus h minus f of a over h. So that's our second formula, if you will, for finding the slope of the tangent. And they'll refer to that as equation 2. And it turns out this one is the one that we'll focus in on even after we finish up our first unit here. That's what we'll focus. Use this equation 2. All right. So let's see how that plays out for some of these problems. Okay. So let's find the slope of the tangent using this equation 2. A couple of problems. First one. Find the slope of the tangent at 2, 8 for the function y equals x cubed using equation 2. Do that. I'll just erase it, but we remember it here. I remember it anyway. All right, so the slope of the tangent using equation 2. So equation 2, we do the limit as h approaches 0, f of a plus h minus f of a over h. I do give, for the test, I do give, first test anyway, I give these definition 1 and equation 2. Give those on the test, so in case you're wondering. All right, but again, like in definition 1, let's first of all figure out what my a is. And a here for equation 2 is just like the a was for definition 1. The a is the x value that I want the tangent at. So what's a here? Well, a is the 2. So let's rewrite the formula here just with replacing a by 2. F of 2 plus h minus f of 2 over h. Okay. This isn't going to be too bad, I don't think. We can figure out what those are. Well, f of 2 plus h means we're going to plug in the 2 plus h in for my x. So that'll be 2 plus h cubed. So it'll be the limit as h approaches 0 of 2 plus h cubed. That's the f of 2 plus h. Now f of 2, so then I would evaluate the function at 2. So again, y is f of x. I guess same thing. So that is the f of x. So f of 2 would just be 2 cubed, which is 8. And then we'll have that all over h. Well, unfortunately, again, we plug in the h to be 0, we get 0 over 0, much like we've encountered before. So we have to do a little work. Let's go ahead, for this one, let's go ahead and cube that out. 2 plus h cubed, we'll cube that out. Right here. 2 plus h, 2 plus h, 2 plus h. It's not that bad to just multiply all that out. 2 plus h times 2 plus h would be 4. Then you got 2h and 2h, so you got 4h. And then h and h, you got h squared. 2 plus h. And then just multiply those in here. Or vice versa. So you got 2 times 4 is 8. 4 times h is 4h, and do the 4h times the 2 and the h, so that'd be 8h plus 4h squared. And then do the h squared, so it'd be 2h squared plus h cubed. So you wind up with 8, so this becomes 8 plus 12h plus 6h squared plus h cubed is what 2 plus h cubed is, and then you got that minus 8, and then you got all that over h. Okay? One way to go there. Now, the reason we do that is, because the 8's go out very nicely there. 8 minus 8, so those are gone. Now what's left? Well, now you got this, which just so happens they all have h in them. So we can factor off an h there. The limit as h approaches 0 still doing the limit. So we factor off an h, so you have 12 plus 6h plus h squared. And that cancels nicely the bottom h. Now we can do our h is 0, can't we? We got 12 plus 6 times 0 plus 0 squared. We got slope of 12. Yes? How's that? All right. Well, let's do a couple others. See what else we can run into here. Any questions about that? Does that look okay? So far, so good? Hopefully not too bad. All right. Well, let's see what we got on this one. Find the equation of the tangent line at 4, 2 for y equals x over x minus 2. Find the equation of the tangent at 4, 2 for y equals x over x minus 2 using equation 2. They'll specify in your homework, they'll specify use definition 1 or equation 2. But let's use equation 2 for this one. All right, well, how does it work here? So the slope, if we want to find the equation of the tangent, we've got to start with the slope of the tangent, which is, using equation 2, the limit as h approaches 0 of f of a plus h minus f of a over h. In this case, the a is the x value, so that's 4. So you have 4 plus h. Let me go ahead and just write it here. So it'll be f of 4 plus h minus f of 4 over h. Limit as h approaches 0 then is what? We plug in the 4 plus h here. 4, this is f of x here. Y is the f of x, so that is f of x. So f of 4 plus h just means wherever we have the x, we put in a 4 plus h. So the top would be 4 plus h, and the bottom would be 4 plus h minus 2. Okay? Then f of 4, well, the same thing, we input 4, so it'd be 4 over 4 minus 2 over h. That's our start. Now, these do simplify a little bit. First of all, 4 plus h on top here doesn't, but the bottom does. We've got what? 4 minus 2, so we've got 2 plus h here. Or h plus 2, either way. Over here, this is 4 divided by 2, so this is, we could just say that's 2, couldn't we? Simplifies nicely. Erase this, because we need a little more space. All right, now what? Well, the way we did it was on ones like these, complex fractions, fraction over fraction. We went ahead and got a common denominator here on top, which, that's 2 or 2 over 1. So all I have to do to get a common denominator, right, is multiply this one by h over 2. H plus 2 over h plus 2, I should say. That's all I have to do on that one. And so that'll get me, the limit as h approaches 0. 4, let's write it all out here. 4 plus h over 2 plus h minus 2 times h plus 2 over h plus 2, or 2 plus h, I don't know why I wrote it in reverse there, but yeah, what that gets me, right, is a common denominator, so I can combine my numerators. Limit as h approaches 0 then, it'd be 4 plus h minus, that would be minus 2h. You gotta be careful with your signs because it's really minus 2 there that we're distributing, right? Minus 2h minus 4 over then the 2 plus h or h plus 2, that is a common denominator. And let's go ahead and, we switched, the way we did divide by h means times 1 over h. At some point, we usually switch that. Yeah, this is going to work out pretty nice. What have I got? Well, the 4's are gone. H minus 2h is minus h. Still not able to plug in just yet because it goes to 0 over 0, but now with the canceling, I can cancel that h and that h. Yeah, it's negative 1 over 2 plus 0, isn't it? Negative 1/2. Which is my slope of the tangent line. Again, it wanted the equation of the tangent line. So I do y equals mx plus b, but I know my slope now, so I can figure out the b. This is a half. And so yeah, just plug in the 4 and the 2 for x, the way I do it. X is 4, y is 2. So 2 equals negative 2. The 4 and the 2 will cancel there. B is 4? B is 4. So it's y equals 1, negative 1/2 x plus 4. Question? Look okay? I do that right? Believe that? We're good? Okay. All right. Well, let's do this. What about this one? Yeah, find the slope of the tangent. For y equals x squared minus 3x at the point where x equals a. And the slope of the tangent for y equals x squared minus 3x at the point where x equals a, using equation 2. right, well, what have we got? Equation 2 is the slope of the tangent is limit as h approaches 0, f of a plus h minus f of a over h. Right enough, maybe becomes second nature there. Theory anyway. Yeah, so in this one, the difference on this one is I don't have a specific a value in mind. So I'm just going to do it in general. In other words, I'm going to leave a as a. There's not going to be a number to plug in there for a. So we're just going to go with this the way it is. We're looking for it at a. So what that means is then, yeah, I'm going to plug in a plus h for my x to the function. So plug it in. That's our input value. So f of a plus h is going to be a plus h squared minus 3 times a plus h. A plus h squared minus 3 times a plus h. Minus then f of a, well, you have to be careful because I am plugging in, for f of a, I'm plugging in the a for the x, and so it's going to be a squared minus 3a, but better think about the signs there. I usually just go ahead, if I plug it in, put parentheses around it because, right, that minus, I've got to subtract the whole thing, the whole function value, so that's going to change those signs. It's going to be minus a squared plus 3a, right, because it's minus that. Okay, well, the way we go about this one, I'd probably just go ahead, let's square a plus h out. A plus h times a plus h, so you've got a squared, and you got ah, another ah, so you got 2ah, and then you got h squared. Yeah, so that's a squared plus 2ah plus h squared. Distribute your minus 3 there, so minus 3a minus 3h. And then we got minus a squared plus 3a. Minus All right. Yeah, when you have these polynomials like this, a lot of nice things should happen. And a lot of nice things happen here because what happens here? A squared minus a squared. Minus 3a plus 3a. We're wiping out several terms there. And what we're left with is 3 terms. But notice what's in common with all those 3 terms. 2ah, h squared, 3h. There's an h in common. Yeah, that should happen whenever you do these polynomials. You should always have a common h that you can pull out with the terms that are left. So we have h times, that'd be 2a plus h minus 3. Yeah, because we need that common factor of h because it needs to cancel out the bottom h, does it? Because we're going to 0. Now we can do the h goes to 0. It's 2a minus 3. Yes? Yeah. Now the beauty of doing it this way is now we have a formula, if you will. So that gives me the slope of the tangent line at x equals a. For any x value, basically. For example, what would be the slope at a equals 2? 2 times 2 minus 3. 4 minus 3 would be 1. Slope of that one would be 1. What's the slope at 5? 2 times 5 minus 3. That'd be 7, wouldn't it? 10 minus. So if you do it this way, you got your slope of any point you want. Wherever you want on that graph, you can find the slope of the tangent because all you have to do is plug in the a to b, whatever it is, whatever that x value is. So that's a good way of doing it that way. All right. Let me hit one more, and tell you what, let me do on this one. I think I'm going to do this one. Let's find the slope of the tangent for f of x equal square root of 3x minus 4 at x equals a. Let's make it, yeah, x equals a. But let's do, since I only did definition one example of that, let me go back to definition 1, just do that definition 1. I hope it works out here pretty well. Use definition 1 to do this one. All right. Yeah, because they want you to do both types. All right, well, definition 1, slope of the tangent, definition 1, so it's a limit as x approaches a of f of x minus f of a over x minus a. Well, let's see what we run into. I'm not sure. F of x is the square root of 3x minus 4. Easy enough. F of a, well, we plug in the a, so we have the square root of 3a minus 4. And the bottom is just x minus a. Yeah, this is going to work out pretty good, I think. That's our limit. No simplifying, because I'm doing it at x equals a, right? So I don't have an a to plug in. How do I do such a limit as that? Got the square roots, because yeah, x goes to a, so it's 0 over 0. With the square roots, what's the trick there, if you will? Conjugate? Yeah. Let's multiply by the conjugate here. So we got the square root of 3x minus 4 plus the square root of 3a minus 4. And we got to do that top and bottom. Well, nice things happen on the top there, anyway. When I multiply those conjugates together, what happens? Well, the square root of 3x minus 4 times the square root of 3x minus 4, the square roots cancel one another out, and we're just left with 3x minus 4, right? Middle terms, well, again, I've been through it in a couple days, so square root of 3x minus 4 times square root of 3a minus 4, nothing happens there, but we've got a minus counterpart. So those are just going to cancel out. And then we got the minus square root of 3a minus 4 plus times this plus square root of 3a minus 4. Again, the square roots are going to cancel. You have to be careful though. It's going to be a minus of 3a minus 4 without the square root there. Right? Minus of that. Is that okay? And then the bottom, we're just going to leave it x minus a times square root of 3x minus 4 plus the square root of 3a minus 4. Don't do anything with that, really. Don't multiply that up. good things do happen on top, because that's going to make that a minus 3a, and that's going to make it a positive 4. So aren't the 4's going to cancel? 4's going to cancel. So we're just going to have 3x minus 3a on top, which that does have a common factor of 3, so let's write it this way. So that's the limit as x approaches a of, so I'll factor off a 3 there, so I have 3x minus 3a, 4's are gone. 3x minus 3a is all that's left. Factor off a 3, so it's 3 times x minus a. Well, that goes really nicely with what's on the bottom. Cancels them out. Get it all copied here, right? Plus square root of 3a minus 4. Yeah, that goes nicely, doesn't it? Yeah. Minus a's. Top's just 3. So as x goes to 3, as x goes to a, top goes to 3. X goes to a, so that's 3a minus 4. Plus square root of 3a minus 4. Nothing to plug in because it's the x that's going to a here. So we just change that to a. The bottom, you got 2 square roots of 3a minus 4, so that's 3 over 2 square roots of 3a